Hi everybody, my name is Mark Galswick. I'm the Gas Products Manager here at Dettrônics, and we want to show you some of the features and benefits of a new product of ours. It's called the model LS200. It's a line-of-sight infrared gas detector. Now, the purpose of this product is to look for the presence of unwanted hydrocarbon gases. So we're going to walk you through some of those features and benefits and introduce you to some of the cool things that you might be interested in. Before we dive into our setup, I'd like to briefly introduce you to the three different types of gas detection technology. Those are point detection, acoustic detection, and line-of-sight detection. Now with a point detector, you're going to use that where you need to have an accurate concentration of gas, where it's important that you know what type of gas and how much of it is there. With an acoustic detector, you're going to have a little less information about that gas leak. You're going to need a pressurized gas leak, but you are going to have an expanded range of detection. You can think of an acoustic detector as a sphere, and whereas with a point detector, the gas has to physically contact the product, with an acoustic detector, we're essentially listening for that hissing sound that's made by a pressurized gas leak. So that can be a complement over the top of a point detector. And then finally, what we're here to talk about today is a line-of-sight detector. Now, line-of-sight detectors can be separated by over 100 meters. The system consists of a transmitter and a receiver, and we can detect the presence of gas anywhere in between those two detection points. These detectors are well suited for monitoring fence lines, perimeters, or large areas in between storage tanks, for example. Each of these gas technology types has an application where it's best suited. I've often found that in the field, more than one type of technology is needed to provide the optimal solution and are implemented in order to keep our customers safe and satisfied. A line-of-sight detection system is composed of three main components. The first component is a receiver, the second component is a transmitter, and the third component is the mount that you use to install these. Now for line-of-sight detection, the mount is a particularly critical part because we have to make sure that these units are aimed at each other. Right here next to me is our receiver unit. This is the part of the system that receives the light. On the other end, we have our transmitter. We can think of the transmitter as a blinking bulb that's sending an IR beam from the transmitter to the receiver. Now we need that alignment mount to make sure our transmitter and receiver are pointed directly at each other. We found when we were researching for this project that line-of-sight customers' concerns really boiled down to two or three main categories. First of all, users were concerned with the time it takes to install the product. Secondly, we found a lot of concern around how much it costs to maintain the product. You can imagine if you have a transmitter and receiver separated by a long distance that it can be a challenge to keep them aligned and pointed at each other. And then the third concern is product life. I mentioned earlier that the transmitter is basically a blinking bulb. Well, what we know about bulbs is that eventually they burn out. That's a reality of this type of technology, but a concern of our customers nonetheless. So we set out to make a product that was easy to install, easy to maintain, and offered industry-leading protection for a long period of time. Let's start by talking about the easy-to-install features of the LS200. What we've done is we've reduced the average install time by 60% because we know customers were concerned with how long and how complicated the installation process could be. How did we reduce that installation time by 60%? Well, there's a couple things. First of all, we've expanded our field of view by over 60%. Now, field of view for a line-of-sight detector can be thought of as how far off the angle can the light be and still be observed by the receiver. You can think of the receiver as your eye. If you're reading a piece of paper, you would want to keep it right in front of you and nice and close so that you can read it. As you move that paper off to the side, eventually you're not going to be able to read it anymore. Well, a receiver is the same type of thing. If the light it's receiving from the transmitter is right on, it's going to perform well. If the light it's receiving from the transmitter is off angle, that's going to be a challenge. So we knew that one of the best ways to decrease installation time would be to take that field of view and make it as broad as possible. And that's exactly what we've done. The LS200 has a third-party certified 0.8 degree field of view. That means we can be off axis by 0.8 degrees in any direction and still work properly. The second way we've reduced installation time is we've created a simple and rugged mount. You can see this receiver is mounted to our mount here. The mount serves two purposes. One is to align the product so that we can get the receiver pointed directly at the transmitter. The second purpose of the mount is so that once we get it aligned, we can lock it in tight. I've got two simple adjustments here, adjustment for my vertical direction and adjustment for my horizontal direction. Now once I've got the system lined up, I've got a couple locking bolts so I can lock it down tight and it's not going to go anywhere. Often when we explain this feature called field of view, it's a little confusing. What does 0.8 degrees mean? Well, here you can see an example of what 0.1 degrees would look like. If my system was set up with a separation distance of 120 meters, a 0.1 degree field of view would equate to a 7-inch target. Now if I move to a wider field of view, say I had a product with a 0.5 degrees field of view, you can see that my target has expanded from 7 inches to 3.5 feet. So that's a much bigger target. Now if I take from that 0.5 and go up to 0.8, which is what the LS200 offers, you can see that the radius of my circle is now 5.5 feet. That means I've got a target that's 11 feet across, and the bigger the target, the easier it is to hit. That's why it matters to you that the LS200 has a 0.8 degree field of view. Not only have we made that target bigger, but we've also made the signal strength within that target completely usable. If you're familiar with line of sight products, you know that sometimes the installation process requires us to search for a hot spot within that target. That's not the case with the LS200, and that makes it so there's no need to use an expensive handheld tool to interrogate the target and look for that hot spot. Instead, what we've done is created an alignment tool, and you can complete the installation process using only this alignment tool. That greatly reduces the time it takes for you to install this product. We've also made the LS200 easy to maintain. Now when we're talking about line of sight technology, there's a lot of things that can drive up our maintenance costs. One of those things are when the product falls out of alignment. You can imagine if I've got a receiver and a transmitter separated by a large distance, that it's important to keep them pointed directly at each other. Now things like vibration and shifting mounts can cause that direct alignment to fall out a little bit. And we've reduced the maintenance associated with misalignment by expanding our misalignment tolerance. That's that field of view again. The larger the target, the harder it is for me to fall off that target when I've got a pole that may be shaking or I've got a pole that may be shifting and pointing me at the ground. So first and foremost, it's less likely to come out of alignment because it's harder to come out of alignment, and that's due to that field of view. We've also added some other cool features. One of them are in the category of what we like to call smart monitoring and control. And in there we use our advanced microprocessor to monitor things like power consumption, device temperature, lens obscuration, and we can address each of those situations individually. For example, if we have moisture or condensation buildup on the lens, we're able to sense that degradation of signal, and we can ramp up our heaters in order to evaporate that moisture more quickly. Similarly, with power consumption, if you want to limit the amount of power that the device uses, you can set thresholds inside the software. Also, we can monitor your input power, we can monitor your 4 to 20 signal out, and we can make sure that the device is performing properly. If your input power were to drop too low, we can shut off the heaters to conserve power. The next thing we've done is made the device easy to diagnose. Should you ever have a problem, or should it fall out of alignment far enough that you do get into a fault, we've made it easy to figure out what's going on. First on that list is event logs. If you need to, you can go hook up to the device and you can pull the event logs and see exactly what happened and when it happened. Second on that list of easy to diagnose are these LEDs. You can see I've got a green LED right now that indicates that the device is working properly and ready to detect gas. But say for example I had a situation where I was in fault, and I can simulate that now if I just take the device and misalign it by a large amount. You'll see that within 60 seconds I'm going to get a fault, and I'm going to be able to determine what that fault is by counting the number of flashes of my yellow LED. Okay, 60 seconds have passed, and we can see that our receiver is now indicating a fault condition as expected. I know that because I have a yellow LED, and if I were to count the number of flashes of that yellow LED, I could look at my instruction manual and see exactly what fault that indicates. In this case, I'm getting 7 flashes. That indicates that I'm in a beam block fault, which is exactly what we would expect because I've taken this receiver and I've misaligned it to the point where it's no longer receiving any light from the transmitter, and that is in fact a beam block fault. The last thing I want to talk about is how we've increased the product life of the LS200, and we've added some features that offer industry-leading protection for line of sight technology. First on that list is a 0.8 degree field of view. This is the beginning, middle, and end when you're talking about a line of sight detector. 0.8 degrees field of view is the largest on the market right now. The next thing I want to highlight and summarize for you is the fact that the product can be installed using only an alignment scope. There's no need for that expensive handheld tool, and that does reduce your install time. Next on the list is an increased temperature range. You can see that the temperature range for the LS200 is -55°C to +75°C. That's going to allow it to operate in even the most extreme environments. I'd also like to highlight that we did increase the product life, especially for the IR source on the transmitter. We knew that was a customer concern, so we've created a lamp that will last a very long time. In fact, we're going to warranty that IR source for 10 years, and we'll warranty the whole product for 5 years. There are several tests run in order to achieve product certification. Some of those tests are, for example, ingress protection testing, where we physically hose down the product and make sure that no water can get inside of it. Another example of one of those tests would be our explosion pressure testing, where we verify the hazardous location properties of the LS200 enclosure. Also, we test the product during vibration, where we mount the product to a vibration table and we verify that it can operate during that excessive vibration. And lastly, we verify that the product works in the presence of fog. In summary, I'd like to wrap up by telling you a story about one of our pilot site installations. When we're developing new products, we always pick challenging pilot sites in order to test out the product and make sure that it's going to work properly in challenging applications. For this particular pilot site, we chose a location that was down in a valley. What that means is they get a lot of fog there. It's also a 4-season location, so we get rain, sleet, and snow impacting the device as well. Another challenge of this application, this particular application, is that the pole the device is mounted to is physically loose. Now, we don't recommend that at all. Of course, we hope you have a solid mount, but it was the situation here nonetheless. And then the icing on the cake is they get 4 trains a day going past this installation. What that means is, without a doubt, we've got a line of sight detector that's shaking around, that's going to have snow and rain, fog, sleet covering it at any given time. So we installed the LS200, we completed our entire trial period, and we didn't have a single fault that whole time. In fact, every time we went out there to check the device and make sure that it's still alarmed as it was supposed to, we got the appropriate alarm response. The customer that we installed this pilot site at has been giving us unsolicited feedback with how impressed they are with this installation. It's as bad as it can get for a line of sight detector, and the LS200 was able to come through. It just flat out works, and that's when I personally became a believer in this product and why I'm so excited to get it out there and have people start using it and see for themselves the benefits that it has. For more information, literature, or additional videos, please visit our website at Dettrônics.com.